Hi everyone, glad you could join us for today's session, Myth versus Reality, Understanding AI and ML in QA Automation with our expert guest speaker, Jonathan Lips. Jonathan Lips is a world-renowned test automation expert and needs no introduction from me for sure, but I'll give a short one anyway. Jonathan is the architect and project lead for Appium, the popular open source automation framework, and is the author of Appium Pro, the weekly Appium newsletter. Jonathan founded Cloud Gray, a consulting firm aiming to help global brands and companies successfully implement processes, best practices, tools, and technologies in order to substantially scale up their mobile test automation efforts and release velocity. Jonathan has worked as a programmer in tech startups for over 15 years and holds a master's degree in philosophy and linguistics from Stanford and Oxford, respectively. And if you are not already, I strongly recommend to follow Jonathan on Twitter and subscribe to his weekly Appium newsletter. So without any further ado, Jonathan, the stage is yours.
Thanks very much, Adi, and good morning, afternoon, or evening to all of you, wherever you are in the world. I'm really excited to be with you all talking about a topic which is extremely important and timely at this stage in our technological development as QA engineers and people interested in this subject. So let's go ahead and get started. Adi already gave me a very kind introduction, so I'll just add to that by showing you a picture of what I look like. This is me. I'm wearing the same hat today, so you have a good view of how I am sitting here at my computer talking to you all through the magic of the internet. All right, let's get down to business. The first thing I have for you is quite a remarkable image demonstrating the power of artificial intelligence, namely this device here. If I were in a room with you all, I'd ask for somebody to guess what this is. If I didn't have the branding on this image, we might think it was something pretty fancy, but in fact, it's just a toothbrush. It is a toothbrush being advertised as coming with artificial intelligence. What does that mean exactly? I have no idea what they're trying to sell with this image other than saying something like, this toothbrush is extra fancy and probably worth extra money for you to pay to get all the benefits of artificial intelligence. Now, in reality, they're probably marketing something like, the toothbrush remembers how long you brushed your teeth and will chart it out for you in some connected app. Whatever it is, it's probably ridiculous, probably not something you really need. At least I know for myself, my reaction was to laugh and not to go out and buy this device. So the question which naturally comes to mind with this type of marketing around the topic of artificial intelligence is AI BS? You know, is it actually a real thing? What is it? I found this great quote from an internet individual where we learn about something called a BS industrial complex, which is BS, which I hopefully don't need to spell out for you, taken to an industrial level of scale. And the quote is, the core feature of a BS industrial complex is that every member of the ecosystem knows about the charade, but is incentivized to keep shoveling. So how this refers to AI and specifically marketing around artificial intelligence is that I think we've now reached the stage of being a BS industrial complex when it comes to AI, where everybody knows that when you market a toothbrush as having artificial intelligence, it doesn't really mean anything that special, but at the same time, everybody kind of benefits from marketing their devices or software tools as having some relationship with AI. So everybody keeps doing it. But even the consumers of these products know how to interpret this. You know, this toothbrush is not gonna wake up in the middle of the night and walk over and have a conversation to you about the meaning of life. Everyone knows it's not really that kind of intelligence, but there it is. So I think this is a situation we find ourselves in general with AI. And so in this presentation, we're going to explore a little bit about specifically the industry of QA. Another way of thinking about it is with this really awesome sequence of images, which you've probably seen going around Twitter or something else. We get the feeling a lot of times that when something masquerades as AI, that's really all it's doing. It's just wearing a mask. And if you look a little deeper into what's actually happening with the technology, what you find is just the same sorts of computer programming techniques that we've always been used to. So here we have the image of a bunch of if then else statements. And we all know that we can use computer programming and conditional logic and a whole host of other non-intelligent tools to develop software that in some way behaves intelligently to us. So the question is, how is artificial intelligence any different from any other software technology that we've been taking advantage of for, decades? Really, the biggest question that we have to answer in order to understand all of this is, what are AI and machine learning? And we often see them grouped together. So we need to understand what artificial intelligence is, what machine learning is, how are they related, how are they different? If we don't actually know what AI and machine learning are, we won't be able to unmask any of the marketing and tell the difference between products which are merely putting a pretty picture on something that's not truly intelligent, and other products which genuinely are using the new technologies which are being promoted in so much of the marketing today. So the actually best definition of artificial intelligence is anything a computer does that seems smart. This is not a very helpful definition, but it may be a surprise to you. This is actually pretty much all artificial intelligence means. It doesn't really mean anything specific, although people often have specific things in mind when they hear this term, like robots that act like humans or chatbots that can fool people into thinking that they're real humans, things like that. But AI doesn't really have a standard definition that everybody agrees on. So it just means anything a computer does that seems smart. And computers have been doing things that seem smart for a very long time. In fact, computers have always been marketed as being smart and allowing us to get more work done more intelligently because the computer has its own smarts built into it in some way or another. So in this sense, AI is not really anything new, even though it is being marketed in a new way at this point in history. And why is that? I think it's because we're often conflating ideas about artificial intelligence with the rise of machine learning processes and algorithms. Now, machine learning is a definition, or I should say machine learning has a definition which is quite a bit more specific than artificial intelligence. And one definition was given by this person, Arthur Samuel, that machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Now, this captures, I think, more of what our intuition is about what's exciting about AI, that somebody could take a problem and give it to a computer, and that computer could help solve that problem without having been explicitly programmed to solve that specific problem before. So this is actually a much better definition for what I think we often associate with AI and often care about and often get excited about when tools are marketed to us as having AI or having this kind of intelligence. So let's talk a little bit about machine learning. And some of you may be machine learning experts and have written your own machine learning models and solved problems using them, and that's great. And others of us might not really know what machine learning is other than the broad definition that I just shared in the previous slide. So I think it actually helps a lot for us to dig at least one level deeper into this concept of machine learning and understand a little bit how machine learning works so that we can understand the types of problems that it might help us solve and the types of problems that it might not help us solve, so that we can actually be in a position to judge the value of technologies that are being marketed to us. So there's three broad categories of machine learning that describe different ways of teaching computers or encouraging computers to learn and solve problems for us. The first category is called supervised learning. And basically it's where we get a bunch of data and we in some way tag that data with qualities that are relevant for our purposes. So this could be like finding a bunch of pictures of dogs and then annotating each of those pictures of dogs with the breed of dog, the size of the dog, the color of the dog, any kind of information that we might want the computer to then be able to learn from the example data that we're giving it. There's also a category of machine learning called unsupervised learning, which is a bit different. In unsupervised learning, we don't tag using human authors. We don't tag the data that we feed into the algorithm. We just collect a bunch of data that has its own structure. We throw it into the unsupervised learning algorithm, and the computer, the algorithm, actually builds a model that can differentiate between various examples in the data based on the naturally occurring patterns that it finds. So it's a bit different than supervised learning. Different from each of those is another style of machine learning called reinforcement learning, which basically helps to learn how to act like a human. It teaches the computer how to act like a human in a certain type of environment. So if we're able to construct an environment that the computer can operate in, and if we can define what's called a reward function so that the computer knows when it's doing something good or appropriate in that environment or when it's not, then that computer algorithm can learn sort of by trial and error how to behave in a variety of scenarios within the scope of this highly structured environment. There's another kind of learning that we often hear about called deep learning, and it's not really the same type of category as the other categories we've looked at. Really, it's more of a description of the level of complexity of the problem we're trying to solve using neural networks, which is a specific machine learning algorithm, and how we can handle types of problems that have very complex inputs. But I list it here because the way we talk about deep learning makes it sound like it's on the same level as these other kinds of machine learning, and it's kind of not really. So what are some use cases for each of these kinds of learning? We just talked about it in a very abstract way, but I think it might help to look at some use cases and then some specific examples. So with supervised learning, we might want to classify a new instance of data, some new data that we get from the world, based on a model that we've trained to classify existing data. So it helps us make a prediction about new data based on earlier data that we've seen. Unsupervised learning helps to find patterns in a data set that might be difficult for human researchers to spot, either because the data set is so large or because it's so noisy. An unsupervised learning algorithm can help classify different types of data according to different qualities that the data has, and then surface those to us in a way which might help us see the data in a new light, or help us find patterns that we didn't realize existed, which could help explain reality for us in a new way in a context of a scientific experiment or something like that. For reinforcement learning, we could use it to develop human-like reasoning in a well-defined task environment. So things like playing games and so on. And as I said before, deep learning is used when we want to try and attack problems that have a lot of complexity in their input data space. So some concrete examples. For supervised learning, we might want to predict the species of a flower given certain attributes of the flower. Maybe its petal length, its shape, and a few other details. If we have trained a machine learning model based on the correspondence between petal length, shape, and species of flower, we could theoretically, as long as reality actually works in this way, try and get the algorithm to predict for us the species of a new flower that we don't know just by looking at it, but we can measure its petal length and shape. In unsupervised learning, we could, for example, take a huge library of popular music, millions and millions of songs, and use various attributes of these songs, for example, their length or different sonic qualities, the maximum noise ceiling, how much compression there is in the music, harmonies, whatever attributes of the music we can extract from the songs themselves. We could toss that all into a big unsupervised learning algorithm and see if any groupings of songs are detected by this algorithm that might be helpful for human consumption of this music, right? So if we didn't have all of these songs tagged with their genre, but we felt that there were enough attributes attached to these songs that could reliably predict their genre, we could throw the songs into a big unsupervised learning algorithm and maybe have the computer separate out the songs by genre for us. And then all we have to do is give the genres the appropriate human-oriented names, but we don't have to go through and tag it all ourselves. That's the kind of thing we could do with unsupervised learning. With reinforcement learning, we could teach a bot to compete against humans in a video game. And this is something that has been done with AlphaStar, the StarCraft bot, or has been done with board games as well, like AlphaGo, and obviously some other computers that can play chess and things like that. So reinforcement learning is a pretty good way of teaching bots how to behave in these types of environments, and they can actually begin to behave, in some cases, even better than their human opponents. And again, for deep learning, the idea here is just that we might have a very difficult problem with a lot of complexity in the input. So if you imagine an image of an animal is a very difficult thing to use to predict the species of an animal, because the animal could be in different backgrounds or contexts or orientations. There's a whole host of things that make it very difficult to determine the species of an animal just from an image of it. And so for that, we could use deep learning. Okay, so we've talked about machine learning categories, but within each category, there are a number of specific algorithms or approaches that can be used to work within that category for the type of problem we're trying to solve. So for example, if we're talking about supervised learning, the very most basic and simple machine learning algorithm used to build a supervised learning model is actually linear regression, which is basically just learning a very simple algebraic function which can be applied to new inputs and get an output value, which is our prediction based on the inputs for the new data. Another example of an algorithm would be something called Kmeans clustering. And this is an algorithm that's often used in unsupervised learning to gradually and iteratively partition a space. And this can be a space of any number of dimensions. It can be 2, 3, a million different dimensions based on the characteristics of the data that has been fed into it. So again, this is the kind of thing we would use to maybe separate out a bunch of songs by their various attributes, and then we would find clusters of songs, and these clusters could be viewed by human observers as corresponding to something like genre, or maybe something else. I don't know if genre is the best thing, the most obvious thing that this algorithm could learn from all of that data, but that's the kind of approach that we could use to figure that out. Something you've probably heard about is neural networks. Now, neural networks are used for a lot of applications. The idea behind neural networks is that they actually simulate the operation of neurons in human brains to learn how important different values in an input vector are towards an ultimate prediction for the output. And when I say input vector, I just mean the set of things that we care about for each type of input. So if we imagine that our input was an image of an animal, the input vector could be, for example, the pixel data. So you could have an array of pixels with the appropriate color in each of the color dimensions and things like that. So that would be the input vector. So then a neural network would figure out how to weigh the different values of that input vector to ultimately produce an output prediction of, cheetah or dog or whatever the animal is supposed to be. And the idea behind neural networks is that you have these various layers of neurons which all get activated by the different inputs, and the learning process figures out which weightings of the inputs are correct and lead to the best predictions. A kind of special take on neural networks would be something called generative adversarial networks, which you're probably familiar with from the concept of the deep fake, which is now in popular discourse, where you can have videos of people saying things that they never actually said in real life. So the way that these types of algorithms work is that you have a couple neural networks that kind of work against each other. They sort of compete with one another. And one neural network tries to create an example of fake data, and the other neural network tries to tell whether that data is fake or real. And if it detects that the data was fake, then it wins, and the first network goes back and tries again. And so as they kind of compete in this back and forth imitation game, the types of fake data which is produced by the first network gets better and better. So this is ultimately how things like deep fakes and whatnot are produced. A couple images to highlight what we've been talking about. Here's an example of how linear regression works. We're dealing with two dimensions of data here, income and years of post-secondary education. So what we can do is we can actually just plot these on a graph, and we can draw a line that basically tries to find the correct correlation between these two dimensions. And what we find is basically a line. It could be a curve. In this case, it's just a straight line, which is the simplest case. So you can imagine this line is now just a very basic formula we could use to plug in new values. So we could come up with, we could predict that somebody with $140,000 of income would have had maybe 8 years of post-secondary education. Now, obviously, we begin to see the limitations of this kind of approach because, nobody has 50 years of post-secondary education, but there are some people that have millions of dollars of income per year. So again, this line that we're seeing is learning a true fact about the world, but in a very limited domain. And so we have to be careful about using this model kind of at the ends of the spectrum. But this is basically as simple as it gets in terms of supervised learning, generating a linear function based on input data. This set of pictures is an example of how the Kmeans clustering algorithm proceeds. So if we look from top to bottom and left to right, we have these different clusters of data, but the computer doesn't know that they're differently clustered. So the idea is that the computer tries to find these clusters so that it can tag the different dots with their cluster type. So it basically randomly assigns 3 different categories, and then based on the weight of where different, sort of like center of gravity, based on where all these different dots lie, it gradually adjusts where it's drawing the boundaries between these different clusters so that we wind up with the bottom right image here. And what we can do with this is now if we have a new dot show up somewhere, probably it will fall close to one of these 3 clusters. And so we can now know with a pretty good degree of certainty that it should be tagged with blue or red or green. So it enables us to predict what new data should be based on how closely related it is to the previous data. Here we have an example of a neural network operating on an image. So we've got our input layer, which would be, again, various attributes of the image or other data that we might have attached to it. And then we have these different, what are called hidden layers of neurons, which all basically exist to funnel the input data and weigh it in different ways. And ultimately, what we hope for is the correct label to be produced. So a correct value for the label in a list of labels. And lastly, this is an example of the kind of output you would get from generative adversarial networks. So in each of these pictures, generative adversarial network has tried to produce examples of numbers in the left-hand picture or faces on the right-hand picture. So the ones in the yellow boxes are real handwritten numbers or real human faces, photos of human faces, and everything else has been generated by these generative adversarial networks. So you can see that for the most part, they actually look pretty real. There are some faces that seem a bit odd. Like some people seem to have maybe a couple lips or a nose where their mouth should be, but in general, they some of them look quite plausible, and pretty much all of the handwritten numbers look like real handwritten numbers as well. So these are essentially fakes of handwritten numbers or human faces that have been generated by just looking at a bunch of examples of real handwritten numbers or photos of human faces. Okay, so that's our little digression into machine learning in general, and we got that specific because I wanted you all to have a good idea of what machine learning categories are, some of the algorithms, and then the types of things you might think of doing with them. So let's look at AI and machine learning in QA. And I'm just gonna throw up a bunch of screenshots of some of the marketing around this that I found when I was, traveling to the websites of various companies in our industry. So here's a company, in fact, the company which is hosting this webinar, marketing something called visual AI. So we need to talk about what is visual AI? What does this mean? There's another company that's advertising codeless Selenium with AI maintenance. So not sure again, what does AI maintenance mean? We'd have to ask them to find out. Here we have someone advertising autonomous testing. So this makes it sound like it's testing that humans are not involved in at all, like autonomous self-driving vehicles. So again, we need to dig into this to figure out what exactly is meant by this kind of autonomous testing, or what their AI is that can supposedly remove test churn and increase the accuracy and efficiency of testers. Interesting. This other company is actually getting a little more specific and proposing that there are, in fact, 5 levels of test automation, all the way from no automation to machine learning, full automation, auto-generated smart scripts. So here they're actually, claiming to use machine learning in some specific way. Not sure what that means, but yeah, full automation. Again, it sounds like no one's writing any scripts. They even say that your mind can be off with this type of test automation. So very attractive. Who wouldn't want to turn their mind off and not have to worry about test automation? But again, we don't have any of the details here to know what exactly it's doing and what sort of machine learning technology it might be using under the hood. There's another company. It just says that uses artificial intelligence to speed up authoring, execution, and maintenance of tests. This company gives teams the power of AI. Okay, great. Who wouldn't want the power of AI? I love it. But again, it's hard to know exactly what that means. This one is a little more specific. This company is learning the Google News app on iOS, and a robot hand is holding it. So I guess the implication is that somehow there is some kind of learning process, whether supervised or unsupervised or reinforcement, probably the last one I'm guessing, where a bot or robot of some kind is navigating through an app and learning some of its characteristics in some way. So this is potentially a little bit more clearly linked to some of the stuff that we've learned just now. Here's another example. This isn't a marketing page. This is actually part of the product, where what we have is a bunch of different timelines for the duration of an application automation session. And one of the timelines here, it's very hard to see. I apologize. It's a little, maybe I can zoom in. What we're looking at in this timeline here is something called Video Quality MOS, which stands for Mean Opinion Score. So basically, this is a little graph of the quality of a video that's being played over time. So you can see that we have some quality peaks and some quality degradations. But this mean opinion score is something that, typically is left to the domain of humans to decide. The way you figure out video quality is by asking people, how was the video? Because humans care about a lot of different things in video quality than computers do. It's not just, bandwidth or whether all the bytes made it across the wire. It's, was the background blurry versus the human actor? Because if the human actor is not blurry, it doesn't really matter if the background is blurry. People don't tend to care or notice that. So anyway, this timeline here has been generated using a machine learning model that used the video under test as an input and produced this, per second or whatever mean opinion score as output. So this is an example of a true product of machine learning in this sense. So I think we're now in a good spot to examine some of the categories of artificial intelligence solution in our QA industry. First of all, we have solutions that I would consider AI in marketing only, not because I want to say very clearly, not because these solutions are not useful, but because I think that the use of the term AI when discussing these solutions is designed more to attach to, the benefits that people believe comes with AI, rather than because AI is an appropriate definition of their technology. And the reason I say this is because when people hear AI in marketing, the implication is that there's some kind of machine learning going on where the computer is doing something that we don't really understand, but it's intelligent because we've fed it a lot of data or something like that. And to be clear, this isn't necessarily the best way to solve problems. I'm not advocating that machine learning is the right solution for every problem. In fact, a lot of times it's just not. So when I say that a solution is AI in marketing only, I'm not intending to disparage the product that's associated with that, only trying to suggest that as consumers, we might want to make sure that we're not reading some kind of magic or some kind of inscrutable machine learning technology into this product when it doesn't really exist. So this is kind of what I found when I looked at some of the companies that we saw on the slides earlier, where at the end of the day, the main idea is just that we have intelligently designed software that somebody programmed to solve a particular problem, and that's great. And so in that sense, I guess it could be called AI, but it doesn't really use machine learning models or any of these advanced technologies. It just uses more of the same types of technologies that we've had for years and years. And again, that's not necessarily a bad thing, but it does mean that the marketing could potentially be a little bit misleading if what we take them to be saying is that they're using some of these hot new technologies that we've heard about, like reinforcement learning or deep learning or something like that. I think there's another category where we have AI and machine learning, and the focus is on machine learning here, in a supporting role, where machine learning models are used to support QA related features, not as a total replacement for test authoring or test running. So this would be something like the mean opinion score that I showed you earlier, where we're using machine learning to get very interesting and insightful data about the performance and user experience of our application, but at the same time, we're not having it write our tests for us. Another great example would be the way that Applitools works, where machine learning models are used to assist in visual testing, but the point isn't really for Applitools to do all of your testing for you in a kind of hands-off way. It integrates with intelligent human choices about what should be testing. It integrates with intelligent human choices about what counts as a visual regression and what doesn't for your particular app. But it makes the whole process of getting to make those choices a lot easier and a lot faster. So those are some examples of AI machine learning in a supporting role. The final category would be AI machine learning as the primary driver of automation. So this company that promised level 5 mind off automation, this seems to be what they're advertising. Or one of the other companies we looked at, Test AI, where the bots are using probably some kind of reinforcement learning to navigate through the application and learn the types of things that users can do there. These are tests being written and potentially bugs being found by autonomous bots that act on machine learning models and in some way AI. So yeah, there's these 3 different categories of AI solutions, I believe. And again, some examples, something that would be AI in marketing only would be a type of product that, takes a look at user activity logs from an application. So taking a look at, some of your analytics or your website logs to figure out what paths users take in an application, and then generating test scripts from that. Now, this doesn't use any kind of machine learning or AI. It just basically creates a one-to-one mapping between activity logs and test cases. So this is a great idea. I mean, why not use your existing user activity to generate functional tests based on that user activity? But it doesn't involve machine learning, or it doesn't need to, as far as I can tell. Other examples would be capturing multiple selectors for elements rather than relying on a single selector, so that there's always some selector to fall back to in case the selector you initially relied on has changed because of an app redesign. So this is sometimes referred to as self-healing element selectors. This kind of thing can be done just using basic programming techniques, capturing all the different selectors for an element during the initial recording of a test and falling back to the most important ones by using a hierarchy of human-defined selector types, like preferring ID and then preferring class name, or then preferring XPath with some kind of specific restriction. This type of stuff can be done just by coding all of this into a program without needing AI and machine learning. So then I already gave examples of AI and machine learning in a supporting role. Again, image recognition models helping to detect visual differences, or video quality models giving feedback on quality from a sort of human perspective. And again, the last category, basically the only way it works is you just give the AI your app and it gives you back bug reports. That's kind of the holy grail for this type. Okay, now let's take everything we've discussed and try and wrap up with some concluding thoughts. My conclusion from all of this is sort of, in a sense, that AI does equal BS. And I have a star there because there are some obvious exceptions. But in the QA industry, I find more products where AI is being used in marketing only. And again, it's not to say that the marketing is false, because artificial intelligence is a very broad general term, which just means computers doing things that seem smart. So the computer does something that seems smart, it's AI, even if somebody just coded it up using a bunch of if-then else statements. So when I say BS, I really mean it more in the sense of that image, the unmasking image earlier, where AI is being unmasked as just a bunch of if-then else statements. The only reason there's any unmasking to do is because when we use the term AI, we are often trying to imply that there's something extra special going on, something that the computer is doing that we couldn't have just coded it in by hand, or would have been too difficult, or that requires a real human-like intelligence, which we can't just code in using a couple arbitrary rules. So most of the marketing that I see does focus on what I consider to be AI in marketing only. So the bigger question, though, is not whether AI is BS or not, but do you even need AI in your testing? What type of AI do you need in your testing? Why do you need it? I don't think that we should just be swayed by verbiage about AI and marketing as if that's a silver bullet of some kind. It can be very helpful. It can tell us something very useful. And we've seen a couple examples of genuinely useful AI that is marketed as AI and done so well. But what we need to do as people that are evaluating these technologies is evaluate them based on their return on investment for our use, not based on whether they are supposedly made up of magic AI or not. So if you see somebody marketing to you a solution that enables you to not write tests anymore, sounds great. Give it a try, put it through its paces, see if it works. If it works, it doesn't really matter whether it was built with machine learning models or not. The point is whether or not it works for you. So that's what we should really care about, is kind of blasting through some of this marketing language and being able to ask, hard questions to the product teams to say, what does this do? Will it work in my case? What does it handle? And not to kind of believe the hype that because something is has AI baked into it, that all of a sudden it's going to do magic stuff for me that I couldn't do before. So a handy question you can ask in this type of line of thinking, if you want to probe a product team or a company with, you can ask, what corpus did you use to train your machine learning model? If they're advertising some type of special AI that can, perform better than a human tester of some kind, or give you some kind of advantage in this way, ask them how they train their machine learning model. If they can't answer you, or if they didn't have one to train it, it might mean that their AI is just marketing only. So that's a good question to ask. My prediction is that for at least the next while, most of the actual return on investment for teams will be from AI and machine learning in these supporting roles. So kind of the examples I gave of, video quality checks or visual difference detection, things like that, at least for a while. There are some interesting technologies coming out that have to do with, bots walking through applications and discovering defects on their own. And I think that those should be evaluated, and those will probably continue to get better. But as of right now, I don't see them as completely taking over the role of humans having to think about the types of things that need to be tested. And even when those autonomous technologies do come about, I think it'll be a lot like autonomous driving is today. It'll be more like autopilot than self-driving cars, where it will do a lot of the grunt work for you, but there'll still be some kind of evaluation that needs to happen, some kind of double checking whether the appropriate cases were covered, kind of feeding some of the appropriate inputs into the bot flows, like setting it up with the appropriate usernames and passwords, and giving it a little help here and there. But I do think that it will be an interesting and useful technology to keep an eye on. So with that, I've finished the part of this webinar where I talk at you. I'm really grateful for your attention and would love to engage with any questions that you might have.
Okay, so yeah, we do have a few questions. Just a quick reminder that you can ask questions in the questions panel, of course. And just a quick note before we dive into the questions, I just wanted to let you know that I see all your thank you notes to Jonathan, and I promise I will send all of them to him directly after the session. Okay, so I won't, obviously I won't read them out here, but he will get all of them. So thank you so much for sending those through. First question, have you seen practical case studies of predictive analytics through AI or ML helping teams identify bugs in various areas of a product before testing begins?
That's a great question, and my answer is no, I haven't. I would be interested to know if anyone else has, but I haven't heard a good case study of that type of technology.
What area in automated testing do you see the most potential for machine learning to be applied?
Yeah, that's another really good question. I think different people have different takes on this. Again, the way I see it right now is in getting all kinds of useful information for free along with your functional test. So getting visual regression checks for free along with your functional test, or getting performance reports for free along with your functional test. These technologies often rely on machine learning models to give you very useful feedback that you could theoretically capture yourself, but then you've got to build all this training yourself and so on. Whereas these services or whatever have access to a lot of data, so they can make predictions or make kind of useful reports about what's going on with your application at a high level just by examining a lot of the low-level data that they have access to as a functional test proceeds. So I think there are some other use cases with functional testing itself. So again, some of this, the self-healing locators and things like that. I don't think that it has to use machine learning, but there may be cases where it could use machine learning, especially if you've got teams that are testing a lot of the same kind of app. Like you could imagine a team that's responsible for testing not just a single product app, but a whole suite of apps that have all been designed using the same framework or something like that. You could imagine that there could be some machine learning models that learn rules about interacting with these types of applications that would then be could be used with automating individual apps. So anyway, that's kind of the way I think about it right now.
What kind of roadmap do you see in the future for tools such as Appium? Will AI ML solutions will be inbuilt or segregated from these tools?
Well, I like to think that it will be neither kind of inbuilt nor segregated, but rather that there will be an ecosystem of very easily integratable tools. So this goes to kind of my vision for Appium 2.0, which we're working on at the moment. The idea behind Appium 2.0 is that the individual Appium drivers will be kind of their own parts of a bigger ecosystem, so that anybody could create drivers, anybody can use anybody else's driver that they've created. But where it becomes relevant to this question is that we're also going to be introducing the idea of plugins, which will be little bits of code that can, operate before and after specific Appium commands, or can modify the behavior of the server. So the way I see AI as coming to Appium is that this functionality would be developed as an Appium plugin that people could install and use, and that could augment the way they're currently doing testing, or could provide new capabilities. So 2 examples of this, one that's publicly available right now and one that I'm just working on, but is showing some promise. The first one is an element finding plugin that I developed in conjunction with Test AI, where it uses their machine learning model to help find elements that might be difficult to find using other methods. And there, if you want to look at details on that, you can just search for that in the Appium Pro website. There's several articles on how to use that. Another example would be a plugin that I'm developing right now, which would let you search for locations on the screen that contain certain text using OCR, using object character recognition, or optical character recognition. I forget exactly what that stands for, but where you basically can look for text in an image. So you would be able to interact with elements on the screen by their text, even when you might not have any other way of interacting with those elements or getting them using the UI. So this could be because it's part of the game or something like that. There's also Appium's existing image element finding features where you can use an image template and find a screen region based on that. That uses OpenCV under the hood, which is a project. I'm not exactly sure how the algorithms were implemented, but I'm pretty confident they use some kind of machine learning algorithm to assist with that. So those would all be examples of different plugins that you could install with your Appium instance. And I hope that other people create new plugins that use machine learning models as well and share them with the community.
Have you seen cases where AI or ML could be used to fix issues in the application codes itself, like self-healing, for example?
I haven't seen cases of that. I think typically static analysis tools have provided the most benefit in those types of situations, tools that, you know, explore your application source code and look for potential issues. You know, I'm not super aware of all the static analysis tools that exist for the various, you know, programming languages and app development frameworks. There might be some static analysis tools that use machine learning as a way of figuring out where there could be problems in your application, or it could be you know, opportunities to automatically fix your application. Pretty sure I saw, I forget if it was Facebook or Google or one of these big companies released a tool internally that would look at pull requests and automatically fix potential issues in the code for people. That's an example of the type of thing you're talking about. From the Appium perspective, I don't see it really relating, because again, Appium typically operates from outside of the application. So even if there were a way for some kind of AI plugin integrating with Appium to find issues or find bugs, it would be difficult to know how to report that on the level of application code. I think what you could do is something like use machine learning to learn from a lot of cases of bugs, right? So if you think about your input vector as consisting of like the Appium steps and the screenshot and the type of bug that you found, you could potentially write a plugin for Appium that as it goes through, if it encounters an error, it could try and label the type of bug for you. That could be interesting information for the app developers, but I don't think it, at this stage anyway, could go as far as suggesting specific changes to the application code that would fix that bug. For that, you need a lot more access to application code and knowledge about how that application code resulted in the behavior that triggered the bug.
Okay, our next question is about the ROI from AI and machine learning. So when we think about ROI from AI, the first thing that leaps to mind is that AI and machine learning will take away jobs, the same way that we thought about automation.
Right.
But some people claim that they will take tasks, but not the actual jobs. They will make some tasks easier or automated and not take the entire job, but then it would not really affect the ROI. So how do you see that balance between actually giving up, taking jobs, and actually helping people function better?
Right. I guess I have a lot of thoughts about this. My kind of high-level philosophical thought is, in a, you know, very strictly capitalist context, automation of any kind does imply loss of job function. Doesn't necessarily mean that somebody will get fired, but it might mean that what they were doing before they're no longer doing. And in a lot of cases, if that function becomes redundant and there's nowhere for someone else to go, that could mean, you know, the loss of that job for that person. So I think we have to be kind of clear-eyed about that, and you know, try and put ourselves in positions where, you know, the tools that we use that make our lives easier are helping us to grow in other ways, so that we ourselves continue providing value, again, on this assumption of a certain type of social and business framework, which I'm not saying is good at all. I'm just saying that's kind of the reality in a lot of the world. Personally, I don't think that's the way it should work, but that's the way it does work at the moment. But from a more technical perspective, yeah, I think right now what it's going to do is make it more like the skills that we have to have are the skills of how to kind of train and coach and integrate the AI, and those will be really valuable skills. There'll be different skills than learning how to find element locators and things like that, because that might be a skill that goes away, but it'll be somewhat of a higher level skill. I also don't think that that's going to happen like overnight. I think that we'll see that coming, but I do think that any kind of automation does tend to alter the landscape of what human beings do day to day in their jobs, and I think it's good for us to know what's coming and to do what we can to learn about the new things and to put ourselves in a position where we're helping drive the new thing rather than being driven by it. So I don't know if that's a very happy answer, but that's kind of the way I think about it.
Well, why end the webinar on a happy note if you
Right.
So yeah, so unfortunately, that's all the time that we have for today. I wish I had a happy question for you to answer, but
Well, I think I will say one happy thing, which is that I don't see any of these types of AI actually coming close to achieving the sorts of things that human beings can do in terms of their creativity involved either in testing or in lots of other areas. And I think we should, as humans, insist on that with ourselves. I mean, what I would say as an encouraging note is just because AI, is in the world doesn't mean that human beings have to become robots themselves in order to work with it. So yeah, let's keep being humans and doing our fun and quirky human things, and I think it'll all work out.
hope for the best.
That's right.
So yeah, so I want to thank everyone for joining us today for this live session. Of course, I want to thank our expert guest speaker, Jonathan Lips. Before Jonathan will say his goodbyes, I just wanted to remind you that a link to the recording of this session will be emailed to you by end of day Monday. And I do hope to see you all at our next event.
All right, I had a lot of fun chatting with you all, so thank you for joining Adi and me, and we'll see you next time.